So now we're going to take a look at the next two sections of statistics, which is generally viewed maybe more mathematically. We're doing more arithmetic. We are going to find the middle of the data, and there's different ways to say what the middle is. There's a physical middle, which is half the data is above and half below. That we're going to call the median. There's an arithmetic middle, which we're mostly used to, as that's the average, or what we call the average. Mathematically, that's the mean, so we're going to get there. And then there's one other for primarily its best use is in non-numerical data, like colors, something like that, and that's the mode. It's which one occurs the most often. So we're going to look at those, and then in the next section, 12.3, that's 12.2, 12.3, we're going to look at variation, how spread out that data is. So, in a classroom of high school juniors, the age is pretty close to all the same. I can't remember, maybe it's, how old are they? Juniors are maybe 17 years old, maybe 16 years old, 16 or 17, but there's not much variation. We come to a college classroom, we get a little bit more variation. Students, well, actually, depending upon which college, I've had students from 12 years old to 80 years old in the same classroom. So that's variation. That's the concept. Okay, so we're just going to go into it. We're going to do it all mathematically, and we're going to get this particular part of statistics, which is really what most people think of when they think of statistics. Okay, so this is the measures of central tendency. The central, where is the center of the data? Can we get a single number that represents the middle of the data, the average? Okay, so what we're going to go about doing is something called the mean. This is what we generally think of as the average. Although we could use the word average for all of these as well, and that's where it can get confusing, and sometimes on purpose confusing. But the mean is we add them together, divide by however many there are. Okay, the median is where is the exact physical middle. It's a location. What number is located in the middle part where half the data is below and half is above? That's what we're going to call the median. Think of it when you're going down the highway. The middle of the highway is called the median. 2 lanes this side, 2 lanes that side, or more. But the median is physically in the middle. And then finally, mode. Now they all start with M. That's where it gets confusing. But try to break it out. Mode. I just thought of this. I don't know. Think of a la mode. I love pie a la mode, right? What is the a la mode? It's ice cream on top. What is ice cream? It's not a number. So mode is primarily, it can be used with numbers, but really where it comes about is it's the thing that happens the most. And so data that is not numerical, such as flavors of ice cream, colors of shirts, of anything, that you can't put a number to it, then what you're looking is which one happens the most. What's your favorite ice cream? Chocolate, vanilla, pistachio, whatever it is, that we would use the mode to determine sort of the one that happened the most. And then we'll look a little bit at mid-range. Okay, so we'll get through all of these. The mean, this is just a mathematical, this is a Greek letter here, sigma, and it means sum, which means to add everything together. So you add all the data, all the different X values, right? And then N is how many items we had. So N is the number of items, N for number. X, you're going to have like an X1, an X2, an X3, ... all the way up to X little n. So these are all your data. They're numbers. Okay, so you add them all together. X1 plus X2 plus X, oops, to make the X big, the number little, ... So it means there's whatever's in between there all the way to the end, we add them, plus, 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 and then there's n of them, 50 of them, whatever, you divide by that. Okay, and so they say that again in words. This is the sum, the number of items. I didn't even see that. Okay, so let's look at some examples. Calculating the mean. So inventors born or made. Would it be nice? So this, can you learn or are you born an inventor? So some are inventors born or made. So inventiveness can be learned, inventiveness can be is inherited. So this is the group over here. I guess that's kind of an orange, that think that it's inherited. The teal color is feeling that it is something that can be learned. And again, they do it by country. So let's see where they're going with this. Calculating the mean, continue. Find the mean by adding. Let's go back. I don't see them finding any mean. This kind of looks out of place. Find the mean percentage of adults in the 10 countries who agree that inventiveness can be learned. Okay, so here's the 10 countries. So what you would do is you would add all these together. Okay, so that's what they're doing on the next page. You have 92 plus 94 plus 84 plus all. So all of these are going to get added together, and then we're going to divide. Since there's 10 of them, we're going to divide by 10. Okay. So here they are. Now I'm following along. All of them added together, divided by 10. So if you add all these together, you get 799. Divided by 10 gives you 79.9. This is just some mathematical notation. You will see the mean represented as what we call X bar. That's a bar on top. So so this is red, X bar. And what that stands for is the mean. Okay, it means we're going to add them together. So I like this notation better than the sigma notation, but the sigma notation, it's a little intimidating, but once you figure it out, it's actually very helpful in writing all of this in a very short period place. And then it also reminds us to get it, we're dividing by the number that we have. So we have 10 data items, so we divide by 10. Okay. And that's it to the calculation. Now you've got to be sure, now some of you might do this all in the calculator at the end, divide by 10, but you would need to make sure you have this on top. If you don't have your parentheses and you just divide at the end, you would probably just be dividing the 75 by 10 and not the others. You wouldn't get the right answer. So realize that the mean itself has to be within the data. If we got 799, we know it's not going to be a mean, because look at this data, 92. It's got to be somewhere within this data set. Okay. When you have a frequencies, now there's a couple different ways to do this. A frequency, remember we said, okay, we counted how many we had of each score. So maybe we're looking at grades or something. What you do is you can just list out all the data, and I'll show you examples as we go through, or you can take each of the X values, the data sets, and multiply it by how many times it occurs. So let's say we have a number 10 occurs in our data, and it occurs 5 times. Now we could say, okay, we've got 10 5s, so that's 10 plus 10 plus 10 plus 10 plus 10. 1, 2, 3, 4, 5. And then we have some other data, so we'll just say plus other stuff. And maybe we had other stuff over here, but we had the data of 10 occurred 5 times. We could address it this way because it's very visual. It shows us we have 5 pieces of the data 10. And we would do that for each of them and then divide by however many we had total. And again, I don't know, maybe there's 100 pieces of data, whatever there is. We could do it this way, or instead of writing out all these 10s, we could just say that's going to be 10 times 5. and then there's other stuff here and other stuff there, but we still are going to divide by however many we have, the n. Okay, so it's sort of a shorthand. And notice 10 plus 10 plus 10 plus 10 plus 10 equals 50. So does 10 times 5. So just all they're saying is this gives us a sort of a shortened way of writing things and calculating as well. So we don't have to keep entering numbers again and again and again. Okay. So in this case, the 5 represents our frequency. The x in our particular case here is the piece of data, this particular piece of data. And then this is our 10 times 5. It's the sum of all the products obtained by multiplying each other, blah, blah, blah. Very wordy, but it's 5 pieces of data at 10 is 50. It's 50 either by 10 times 5 or 10 added to itself 5 times. That's really all it's saying. Hopefully it's clear. If it's not, you let me know, right? Okay, so it gives us an n is a total number of items we have, or total frequency. We're going to look at an example, and like this one. So they do stress ratings 0 to 10, and these are the number of people who had a particular stress rating over the 2.5 weeks. Okay. Notice I don't like to read all the stuff first. I kind of like to go to the numbers first. You might be the other way around, but whatever works for you. That's the main thing of this class, is I want you to understand how you learn, how you see things, and then adapting your study learning patterns to fit what works best for you. Okay, so we've got this, a scale of 0 to 10. 0 is not any stress, and a 10. So where do you think you are? Finals week, we're mostly down here, right? But when we watch our breath and meditate a bit, we could be up in the range, up in the zeros, maybe the 1. Okay. So again, the way we could just turn all of this, okay, there's 2 zeros, so this would be 0 plus 0. There's 1 1, so that would be just plus 1. There's 2, so 2 plus 2 plus 2. That's really what this is saying, that there were 3 people who had a 2. But the other way to do all of this is just to take the x value times the frequency. The x value times the frequency. So what I'm doing is, this is x times f, right? 2 times 3, 3 times 12. Rather than writing 3 plus 3 plus 3 12 times, it's going to take up a lot of space, and I don't know about you, I would probably lose count. 4 times 16, I would definitely lose count here, but I just have to take 4 times 16, boom, 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 and I've got my answer, right? 5 times 18, and 6 times 13. Let's just keep going through this. 7. They're going to do it on the other page, I'm sure, but I find, for myself at least, writing these down, it's not 25, 26 people, 9, a rating of 9, 15 people. So if you do that and say it out loud, when you physically do something, it uses more of your brain. When you just sit and think, it uses less of the brain, which is okay, but I find the more of the brain that you involve in an activity, the easier it is to focus, and the longer you're going to remember it, because it's kind of just, what do they call it? Distributed through your brain. Yeah, your whole brain is involved in this, and that's it's called kinesthetic learning. And I don't know, I was a fidgety kid, always getting up and walking around during, I was also fairly verbal. Only when I didn't think people were listening, but they always heard, Anyway, all of this, being verbal, moving, these activities help you to learn. So anyway, we multiply all these out, get their answers, and add them together, right? And then we would add how many frequencies, so we would get a total down here by adding all of these. And let's see, do they tell us I'm not being stressed? They don't tell us how many people, so we would have to do that, but I'm sure on the next page they'll do it for us, so we'll let them do it. But we would get the total frequency here. That's the total number of people that were measured. Okay, so add those together. Actually, maybe the plus should be up here. We'll add them, and this will give us our total. Notice I do not add this stress rating because that would be meaningless. You know, a 10 and a 0 have nothing in common. They're at opposite ends. So it makes no sense to add these data points together. But adding these tells us how many we have. This would be the total, or it'll be our end value. Okay. So we come here and look, they nicely did all our work for us. I wish all the homework could be this way, right? So they're taking x times f here. They actually worked out all the things we wrote down. These are these totals. And let's click onto the next page. I'm sure they're going to divide by the n, which is the total of this column, n equals this total. This is going to be the total on top. So this will, when we add all of these numbers together, this is going to be the sum of x times f. So we will take this x times f divided by n, and that gives us the mean. So here we are. I guess if you total this, you get 151. Yeah, there's a lot there. It's bigger than I want to do. When we total all of these together, again, give it a try, you get 975. And when you take 975 divided by 150, you get an average stress rating of 6.46. So most people were, between a 6 and a 7 on the stress rating scale, on average. Okay, so we could take this for a group of people, and then you could compare that average. Is it going up? Is it going down? Something like that. But remember, this only tells us averages. I'd like to be one of these two people who has absolutely no stress, or maybe I don't. Sometimes we want some stress, right? For excitement, something to do. So maybe we want to be down here. Remember, stress is not bad. It's only when it becomes distress. Distress is is dependent upon how we react to it. So stressors around us, they're always happening. It's how we respond. And actually that's what this rating is probably mostly about, is how you're responding for stress. These two people they're probably living in the same situation. Say this was an office or something. They may be having the same situations, they just respond to the stress differently. Okay. You might think, well, the boss, he has no stress, or she has no stress, right? I've had a lot of bosses, and usually they're down here. I was always down here. I never stressed about anything. You get done when you get done. Okay, we'll keep moving. This is statistics, right? So now that's the mean. That's all we have to worry about. Add them together, divide by however many there are. If we have frequencies, we've got a sort of a special way of doing it, a shorthand way of doing it. So we didn't have to write out 151 pieces of data, add them all together, and then divide by 151, right? What we did is we only had to actually do 10 calculations instead of 151 calculations. That's kind of a cool method with the frequency, if we have frequencies. Okay. Now, when we're talking median of data, it's the middle. It's a location, not a calculation. Okay. The mean we calculate, add, divide by how many there are. The we locate. It's no calculation. You sometimes use some counting methods, but we're locating it. Where is that middle? So we might count from this side and count from this side. The median is the thing. We went 5 this way, we went 5 that way. The median is the thing exactly in the middle. Okay, that's what we're going to be doing. So here's some things. So the thing though, that you gotta, a lot of times we'll miss this. You have to arrange the data from smallest to largest. You could go the other way around if you wanted to. Just the middle will still be the middle, but it has to be in order. And typically we will go from smallest to largest. Okay, so that's always the first step. Now, if you're using a calculator that has a median function, which there are those, you don't have to enter them in order. The calculator will do that. But if we're going to do it on paper, we're going to want to put it in order and then find it. So there's two things that happen. If there's an odd number, so this would have been 5, that's 10, that's 11 pieces of data. So an odd number, there will be a middle piece of data, right? That's sort of the definition of being odd, is we have the same number on both sides and then one in the middle. Artistically, that's why a lot of cultures actually prefer odd numbers, is because you've got some symmetry. You can make symmetry with odd numbers. The odd number, there's a middle, and then there's the same on each side. So symmetrically, odd numbers are a little more beautiful than even numbers. Mathematically, we tend to think of even numbers maybe being more beautiful. I don't know. Anyway, the median is the data item in the middle of the list. Now let's think what happened if we had an even number. So if we would have only had 10, what we would have done is we would have come 5 this way, we would have come 5 this way, and what we would have got is we would have got a piece of data here and a piece of data there. We would have got between the data. There's nothing here, okay, because it's even. There's only 10 pieces of data. The middle is a space. And so what we do is we take these two pieces, this one, let's call it A and B, we add them together and divide by 2. So we find what is halfway between those two numbers. So notice the median in this case is an actual number in the data number. So the median is actually at one of the measurements. Over here, depending, it may not be. Now that these two are the same, you add them together, divide, you get, so say they were both 20. 20 plus 20 is 40. 40 divided by 2 is still 20. So it's possible, if these are the same values, that this median is one of the data values. But typically, it's not going. If those are slightly different, it's going to be halfway between them. So the median is not in the data. Maybe I'll put maybe. So there is an option where it could be, but it's not required to. But if you have an odd number of data, your median will always be one of your data, one of your members. Okay. So let's look at some example. So some people just want to go, okay, let's just find the median. It's going to be 98. That's the one in the middle. But what did we forget? We forgot to arrange the data first. So let's see, 84 is the smallest, so we have to rewrite it. Then 88, then 90, then 95, and then 98. Which one's in the middle? Well, I can't change colors easily, at least. I can if I go down here, but there's our middle. We call it the median. And it's because there's 2 here, 2 here. So with smaller numbers, it's generally easier to see the median than when we have a large number, but we could still find it. Okay, so they did it all right here. Again, I like to kind of do it by hand as well because it just sinks it in. Okay, so they've done all the steps. The median is 90. You know, so it's just a data set. We did not calculate, we located. Here's another one. Oh, more numbers. Okay, so we'll let them do the work. Okay, so you've got to reorganize this. Okay, so there's a 7. They put that, you might cross it off, and then 13, 15. So they put it in order for us. That's the first step, right? 7, 13, 15. So we got those guys done. Then we jump, looks like 25, 28, 34. So you got rid of these guys, and then what's next? 47. See, it's easy to make a mistake here in ordering. Again, it's something we've learned from a long time ago, but it's also tedious. See, did I get it right? Looks like at least I matched what they got. Now, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 pieces of data. So this is an even number. So what we do is since there's 10, it means there's going to be 5 on this side and 5 on this side, right? 10 divided by 2 is how, and this 10, remember, that's the number that we have. So we do sometimes do a little bit of calculating to locate, but we're interested in locating. Okay, so I come 5 from either direction, and that tells me, okay, after the fifth one, then since it's even, the median's going to be right here in the middle. Well, how do I get halfway between these two numbers? That's what we're getting with the median. We add them together and divide by 2. So watch this, 28 plus 34 is 62, divided by 2 is 31. And if you think about it, you look about it, 31 is halfway between 28, 29, 30, 31, that's 3. 31, 32, 33, 34, both 3 from both directions. Okay, so 3 this way, 3 this way. It gives us the middle number, or what's in the middle. But notice 31 is not part of the data set itself, but it's what we would call the median in this case. That's all we can do. That's all there is. So a little bit of calculation to find the location of the median. Okay, so let's spell our number of letters in the 9 longest words in the English language. So that's how you sort of take, words that are letters, turn them into numbers, find the median number of letters in the 9 longest words. I don't know what value this has, but maybe if you're an English major, you see a lot more value than a math major would. So there's a word with 45 letters, really? Explore the number of letters in the 9 longest words. A word with 45 letters. So now I'm wondering what words these are. Anyway, so the median is the n plus, because there's what it tells us up here, 9 longest words. So we've got an odd. You might think, well, what would be the middle? So you can do, this is one way to do it, is 9 plus 1. So however many there are, plus 1 divided by 2, that will give you that middle position. Because if you take 9 divided by 2, what do you get? 4.5. So it tells me what helps me with this. Another way to do this is 9 divided by 2 is 4.5. So what it tells me is I go 4 from the left, 4 from the right, in the middle piece, that 0.5. So if I go 1, 2, 3, 4, and 1, 2, 3, 4, there's my middle piece. That's how I see it, with a little bit more symmetry. They're going by with a more mathematical, that, hey, just go to the 5th piece, boom, and that's going to be your median. But to me, it's abstract. Counting these 4 and these 4, and that this is in the middle, that's more concrete for my way of thinking. Either way, the median is 28. So you've got two different ways to do it. Use the way that works for you. Take the number that you're given, plus 1 divided by 2, that will give you the middle piece. Or just take the number in, divided by 2. You'll get a decimal, but what it tells you is the whole number part tells you how far you go, and then there's 1 left over, how far you go, and then there's 1 left over. The thing I like about this is it works in both cases. If I had 10 divided by 2, I go 5 in both directions, and it tells me there's nothing left over, so I've got to do that calculation to get to the middle. So Little Crow is just say take n divided by 2, and that kind of tells you how far you come from both sides. I kind of like that. If you get a decimal, that means there is something there in the middle because it didn't get counted. If down here you get no decimal, then you've got to do that calculation of finding the middle point between two numbers. Okay, either way. Now, what if we have a frequency distribution here? This is a little bit more complicated, but it relates back to what we were doing. And this is why, sometimes in math, we say, I got an easier way to do it, so I'll do it. But the reason they're teaching us a harder way is because later on it's a little more helpful. But again, I'll show you my method would work just as well. Okay, so we need to find where is the middle piece. Well, what we've got to focus on is how many pieces of data do we have. And remember from here, they calculated it for us. It was 151. So what we know is how far do we go from each side? Now they do it with their n plus 1 over 2, and they come up with 76th position. Little Crow would have done just n over 2, which is 151 over 2, and notice I'm going to get 75.5. So what it tells me is I come 75, and then it's the next one, because it's partial. It tells me that there's one left over. So it tells me the same thing. Either way you want to do it. I just, when the formula is even a little bit more complicated, n plus 1 over 2, harder for me to remember than just take the number divided by 2, which always works. And in this case, since I've got a decimal, I know that the next number is the median. If it was even, I would have gotten maybe 75.0 or 76, but there'd be no decimal, and then I'd know I have to find halfway between that. So what we do is now we start adding these together. 2 plus 1 is 3. 3, so that's this one. Then I take it's kind of a running total. 3 plus 3 plus 3 is 6. Running total. 6 plus 12 is 18. And then let's see, am I doing this right? Yeah. 18 plus 16 is 20, 30, 34. Getting closer. 34 plus 18. So by the time I'm down to here, I've got 30, 40, 52. So notice I'm just adding these two together. Now I take 18 plus 52, and that'll give me 60. That'll give me 70. Oh, I'm so close. I need to get to 76. I don't need to add this last one because I know 6 more puts me right in this, right there. I'm in the sevens, right? 70, 71, 72, 70. So I don't have this. There's a bucket of these. There's 31 of these sevens. I'm not getting through it. 7 is my median. Okay. So see, again, we're locating it. We use a calculation process to get there, but what we're really doing is locating. We don't know exactly which one of these 31 sevens is the median, but we know that there's just a bunch of sevens in here, right? And that way, in some sense, even if this was even, if I went to the 75th one, it would still be 7, because halfway between 7 and 7 is still 7, right? So with these frequencies, oftentimes, this is how we do it. We figure out which one is the middle and we come. Now, maybe if I would have been smarter, I would have gone this way, 14 plus 15. I want to show you because that's what sometimes I think of these after I'd done all the hard work, right? I came down this way. 14 plus 15 is 29. 29 plus 26 is 40, 55. 55 plus 31 is 80 something, 86. So I know that coming from this direction, I'm also going to hit level 76 somewhere in here. So I still have the 7. But notice I only had to do 1, 2, 3 calculations. So that's the beauty of it. You could come from either direction. Okay, but 76, if it's the 76 one, actually, we came either 76 and boom, there it is, or 76, boom, and there it is. That's what's the nice thing about symmetry. Okay, so far, so good. I think we're on the mode after this. Oh, well, they're going to do it all. So they're kind of doing what we did, you had them all together. We count down the frequency column. What are they doing here? Oh, they're going through. So this would, we're at 18. So this is this is too much work for me. I just, yeah, we're at 18, so don't worry about all these individual ones. 16, you add 16 more, we end up with 34, right? Right? Let's look at this. At 4, we were at 34. 4, we were at 34. Just count it down because we're looking for one's place. You know, too much numbers. I'm going, what is it? But they are showing that you got all 76, and there you are. So it does work, but again, the way I would do is I just add these numbers until I get to the 76 is going to be in here. Or when I got to be my smarter self, I saw, hey, Little Crow, you could have saved some time coming from the other end, and then you'll get to 76 in here as well. So 7 is your median. Either way, we're locating where is that median? It's here. Okay, you just sort of had to eyeball it. Okay, so where is 76? It's somewhere in here. And again, I think that's overkill. It even took me a while. Yeah, you don't want to count 76. Let's not do that. Okay. So this is one. Mean and median. Why do we have two measures? Well, here's the thing. Is we're going to take a look at this example, and we're going to, because sometimes they will just refer that the average salary is blank, but they don't say, technically you could call the median an average and you can call the mean an average. So the word average has really little mathematical meaning because it could be done in two different ways. So let's see what happens. So here's 5 employees. We've got someone making 19, a 20, a 21. The most of these workers are down in the 20s. But the manager, because they get a big bonus, right? They sit on their, okay, that's just me. I was always one of these working guys. And much the manager seemed to be sitting around. Okay, they've got stress. They've got to know things. But a lot of times they were just related to the owner, and that's why they get the big salary, right? But if you do the average, what's going to happen is this $95,000 salary makes it look, right? Here they're going to do the solution for us. Well, they do the other one first. So I guess we'll stick with me. We'll stick with the median. We'll do it in their order. I would have gone for the mean. What we're going to see is the mean actually is much higher. Okay, so we put the salaries in order, which they were pretty close. In fact, they were already in order, so that's good. And we notice that there are how many employees? There's 1, 2, 3, 4, 5, 6. There's 6 of them. So halfway between, so 3 and 3, halfway between, it's going to be right in here is where our median will be, somewhere between 21.5 and 22.6. And so we add the 2, divide by 2, and we get our medians, 22,500. Now, for an average salary for this particular manufacturing plant, that makes sense. On average, a worker is making this. We would typically look at management as separate because they have a separate salary structure. And notice whether they're making 95,000 or 2 million a year, it would not have affected the median. So the median is less affected by things like this 95,000, which we call an outlier. Not that it's a liar in the sense that it doesn't tell the truth, but it's a liar in that it's laying down outside the rest of the data. So an outlier means it's kind of data that's way out there. So everybody's salaries are around the 20s, one salary up in the 95,000. Okay, so an outlier, it does not affect the mean as much. Does not affect the median. Is it affect or effect? Not affected. Not affected by outliers. Okay, and that's why they use it for houses. You could have this huge mansion in a neighborhood of smaller houses. You would still, if you use the median, that tells you what the average house in that area is. Okay, now let's take a look at what the mean salary is going to be. Mean is you add them all together and divide by 6. Notice we ended up at 33,000. So for publication purposes or for negotiation, the management want to say, yeah, we're paying an average of 33,000 to our employees. Because maybe the owner says, okay, that manager is one of my employees. It's not a lie, but it's not accurate, really. For those who are working, what are they living off of? 20,000, not 33. They would love to have an average salary of 33, but you're going to have to bump everyone's salary by about $10,000 here to get the true average up closer to this, right? All of these people. So that's about a $50,000 range. And we could just take it from the manager. He's probably not doing any work anyway, right? Sorry about that, but yeah, managers. I got my brother is into management, a CPA and stuff, and he would beg to differ with me, but I'm just a working man. That's what I see. Okay. So now we're ready for the mode, the a la mode, as I call it. A la mode. So this is dealing with really quality. So it's just simply looking what piece of data has occurred the most. We can use it with numbers. It's typically used with frequent. I mean, actually, that's what you're counting is the frequency of occurrence. So it's something that works well if you're counting the some qualitative item, such as a color, a flavor, a style, something that's not a number. We will use them. In fact, in those type of situations, the only thing we can use is the mode. So we're thinking of most of the data is like that. Okay, so let's go ahead and take a look. And most of the examples are numbers, but again, where this is of best use is when we have non-numerical data. So we see that there are 2 7s, so 7 occurs the most, so we'll say the mode is 7. Now that doesn't necessarily help us with finding where the middle is, but maybe we're wanting to find the response that occurred the most. That's the mode. Okay. Simple. We didn't have to put them in order. We just had to count. Everything else happens only one time. Okay. That's all there is to the mode. So not much else to do it. Now you can have 2 modes because let's go back. Say I had one more piece of data. Say I had a 2 here. Then the mode would be 7 and 2 because 2 happens twice as well. So we could have something that has more than one mode. This would be called bimodal. And there we are. Okay. Now if I throw in one more 7, then again my mode is back to 7. The fact that I've got 2 2s doesn't matter. This would give a mode of 7. Okay. So there'll be some examples. Mid-range, what you want to find, it's when you have a lot of data, a lot of times you just want to find where's the middle, take the high and the low and divide by 2. So we kind of do this when we were finding the median of an even set of numbers, right? We had to find halfway between 2 numbers. So this gives us halfway between the low and the high. Add them together, divide by 2. That's the middle, what would be the middle number, but we call it the mid-range. Again, when we have a large set of data, it's a quick, easy way to get where is the middle. It may not be the median, it may not be the mean, it may not be the mode, but it is the mid-range. Okay, so it's a quick estimate, and it's sometimes helpful, sometimes misleading, just like everything. Okay, so here we can get a Newsweek magazine, factors that affect women's lives, including justice, health, education, economics, and politics. So using these five factors, the magazine graded each of 165 countries. So there's 165 pieces of data on a scale of 0 to 100. The 12 best places to be a woman and the 12 worst places to be a woman are shown below. Find the mid-range among the 12 best countries to be a woman. Okay, the mid-range. So what would be the mid-range score? So again, we've got 12 here, the best place come back here, the best places. So all we do is we take Iceland. Iceland's the best place. I got some friends from Iceland. It's kind of a cool country. Very cool, right? At least during months. And then France is also in the top 12. But so what we would do is define the mid-range. You take your 100 plus your 87.2. I don't know why they're doing dollar signs. I think that's bogus. These are not dollars, these are points. Okay, so you add them together, divide by 2. So 93.6 would be the mid-range. That really doesn't have a lot of meaning, but it tells us sort of, here's the mid-range. And so as far as point values, 1, 2, 3, 4, this is the top 4 is in the mid-range. And so it's not like where's the, since there's 12 of them, it's not like this, the exact middle of the 12, but it's a mid-range. Okay, we could do the same thing here. Worst place, I guess better if not to be in Chad or Afghanistan. And again, it's culturally based. But if you're looking for justice, what are we looking for? If you're a woman looking for justice, health, education opportunity, economics, and politics, and really who isn't? Well, maybe not politics. I'd like a place without politics, but it seems like in this world there's always that. But get rid of the politics. Give me a good economy, good education, health, and justice. And I don't care about the politics that make that happen so much, as long as everybody has good justice, health, and education. I don't care whether it's a monarchy, a democracy, a communist, anything, as long as we're all having justice, health, education. The politics really doesn't matter how it happens, but unfortunately, there's not many places where it really happens well, except what we see, Iceland. And so I figure, if you go to Iceland and they're treating women well, that's the best place, that maybe the men are well treated as well. And maybe those men are maybe, in a native culture, how a man treated the women really told you about the society. So I don't know if I told you this, but and again, I'm going off a little bit because we're almost done. My culture is matrilineal. Our government, our politics was the elder women, because they had children, they knew life more than the men, who were usually out hunting and killing things, protecting in the wars, but they were always, men were involved in this killing side. So our people saw them not as connected to life, and we wanted our decisions to be made by people who were very much connected to life, and that's the women. We've got to say that. So I'm going to say in Canada, I know I've been up there. I've been wanting to become. I'm actually. Because of my heritage, I'm also First Nations. From my grandfather was Chippewa Cree. The Cree are up into Canada mostly, so much of our people are up there. So from an ethnic side, I can apply for First Nation status up in Canada. Actually, I have. There's a small group that are Cree that. So I've got this little card. I don't know how much. Weight it carries, but it was an elder that did that for me. But the Canadians, great people, and they're much more peaceful for the most part. So anyway, a little bit of math, but as I told you, I would rather have been a history teacher or justice studies. Actually, I'd like, if I could do it all over, I'd go for justice studies. Let's back up. So yes, you could have cut me off earlier. We're going to take a slight break here. I'm going to make a new video for 12.3 as we get into dispersion. So that's all. Finding the middle of the data, mean, which is the average, add the arithmetic average, we add them together, divide by how many you have. Median, we locate the middle of the data, okay, median. And then mode, we count the frequencies, and whichever one has the most frequency, that's the mode, okay. So take a little break, maybe go work on 12.2, and then when you're ready, there'll be another video for 12.3. Thanks.